might go 5.
All right, linear inequalities in two variables, section 2.5. If you can remember graphing functions and graphing equations from section 2.3, you can do what we're doing today. Okay, it's just further with graphing, so more review of how to graph. The only difference now is today is instead of doing equals, we're going to do inequalities. So we're going to do, less than, greater than, less than or equal to, and greater than or equal to. All right, a linear inequality. Linear inequality, again, comes from the root word line. So we're going to talk about a line inequality. Now, inequality meaning less than, greater than, less than or equal to, greater than or equal to. Okay? So now again, instead of having equations, we're doing inequalities. So we're going to look at something like this today. Y is greater than 1/2 x minus 7. With which the other day we would have had something similar to that, but it would have said, y equals 1/2 x minus 7. So the only thing changing today is instead of equal signs, we have inequality signs. And really we're going to graph them all the same. If I have that inequality or that equation, what is my y-intercept, Lane? -7. So the y-intercept would be -7. And my slope would be, what would you say, Nick Kalin? Hey. And then I could graph it from there. Okay? And then we have a boundary line. Boundary line is basically what cuts our graph up. So we're going to have today, the other day when we graphed it, we had solid lines. The only thing we're adding today is we could have what is called a dashed line. Okay, we are going to add what's called the dashed line, and we're going to graph with a dashed line as well. Okay. Tips page here. This is kind of helpful for how to graph. Okay, so for an inequality with less than or equal to, I'm going to shade below the line. So if it's less than or equal to, I'm going to go below the line. What that means here is if I have a line, I'm going to shade all of this area below it. Okay? Now, if you think about it, that makes sense. What does less than mean? Everything lower. Less than it. Okay, want a graph, that's lower. That's less than the graph. That makes sense. The next one there is if I have a greater than or equal to, I'm now going to shade above the line. So again, if I have a line like this, I shade all this area above. Well, if less than is lower, greater than is above, that makes sense. Okay? Now here's the one that students usually mess up on. It's when do you put the dash and when do you put the solid line? Well, the dash boundary line indicates that the line is not part of the solution. Essentially, I put a dash boundary line when I have less than or greater than. That's when I have now my dashed boundary line. And that's because less than or greater than, it is not part of it. So if I said, hey, y is less than 2. 2 is not part of the solution. It's everything lower than 2. Same is true for a dash line now. The line is not part of it, but everything below it is. Okay? And then the opposite would be the solid boundary line. That would be for a less than or equal to or a greater than or equal to. And that, again, would be a solid boundary line. Okay, and I like to look at it as if you have the line below, you connect the lines on the line. Okay, so you kind of can see that. If it gives you a line, you connect the whole line. Okay, and then as always, you can always choose a test point to check it. You can always do checkpoints here. Does anybody know what the most popular test point to check is? What's probably the easiest one to use? Not 1 actually. 0, 0. If you want to use a point, usually the easiest one to use is 0, 0. The second popular one might be 1, 1, a pat. But 0, 0 typically is your best test point to choose to check whether you're right or wrong. All right. Next page, very similar to what that last one was. Again, this is kind of showing you what you would do. I'm given an inequality. Okay, so I'm given an inequality there. Y is less than or equal to 2/3 x plus 1. And again, I treat it just as if it were an equation. I'm really going to look at it just as if it's an equation. Okay, I have a slope and I have a y-intercept. Well, on the graph, I start off plotting my y-intercept. From there, I do my slope, which is 2/3, so I go up 2 over 3. Okay, and I get my dots there. Or I can go down 2 over 3. All right, so plotting and graphing, that's all the same. I could give you that equation from the other day, and you can probably graph that, hopefully. The only difference now today is, well, do I have a solid or dashed line, and then am I going to shade below or above? Okay, so I'm looking right here. Again, draw a solid boundary line for those. Draw a dashed for those. Well, it was a less than or equal to, so I'm going to have a solid line going right through that. So it's solid. And because it's less than, it's lower, I shade all of this area lower than that graph. Okay, and then they use the test point 0, 0, and they plug 0, 0, 0 in, and you get 0 is less than or equal to 1. Yes, that checks out. That is true. Okay, so let's look at a problem here now. So number 1, I want to graph the inequality y is less than x minus 1. So I'm given this inequality here, y is less than x minus 1. Anytime I graph, again, slope-intercept form is by far the easiest form to graph. Okay, and I'm going to treat this just as if it were really y equals x minus 1. What is my y-intercept on this inequality? What's my y-intercept, Nolan? What's the y-intercept?
I don't know.
Pat? The y-intercept is -1 because it's that constant usually right there in that form. Right? So y-intercept is -1, so I'm going to go plot -1. Now I'm going to find my slope. What is my slope in this equation or inequality? What's my slope? Colin, what's the slope? 1 over 1. So from my y-intercept, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Or I could go down 1, left 1. Okay, now comes the new part. I'm looking at my inequality. Is that going to be a solid or dashed line, would you say? That is a dashed line. Nice job, because it's less than. It's not included. So I have a dashed line. Am I going to shade above or below? I'm going to shade below. So there would be your answer to problem number 1. So again, just review of graphing, just like we did the other day. The only difference now is, hey, I might have some dashed lines. I'm looking to see if I'm going to shade above or below. All right, let's try number 2 here. It says graph the inequality y is greater than 3x. So again, want to use slope-intercept form. So it's really just like graphing y equals 3x. Okay. What is my y-intercept here? Who can tell me my y-intercept is?
0.
It is 0. Yeah, on a problem like this, everybody wants to think, oh, it's 3, it's 1. If they don't give it to me, it's just like saying there's that plus 0 right there. So my y-intercept is 0. So I go plot my y-intercept. Now I'm going to find my slope. What is my slope, Autumn? What did you say? Very good. So 3 over 1. So I go up 3 over 1. Or I could go down 3, left 1. I get my points. Solid or dashed line? What would you say here, Schultz? I'm looking at my inequality. That is a dashed line. Very good. And would I shade above or below? What do you see? What do you think, Shanks? I'm going to go above. Nice job. And there's my answer right there. Couple more. Y is greater than 2. Now, again, problems like these, we always go back and we forget. This is a special type of line. Okay, if I think about it as y equals 2, who remembers what type of special line this is? Kelly, what type of line do I get? I get a horizontal line because technically, what is my slope here? 0. That's like saying y equals 0x plus 2. That slope is 0. Okay, so I go to 2, and I put my horizontal line here, my dots, that's where it is 2. Would I have a solid or dashed line? What are you thinking here, Harvey?
Dash.
That is a dashed line. And would I shade above or below that dashed line? What do you say, Destiny? Above. I would go above it, line. Nice job. All right, try this one on your own. Take a couple seconds, try this one on your own. All right, let's go through this. If I look at it, my y-intercept is 1. So I'm going to start out here at 1. My slope is 2 or 2 over 1. Solid or dashed line, what do you say, Marisol? Dashed line. And shade above or below, what do you say, Jersey? So all that area right there. Nice job. All right, try this one as well. Take a couple seconds, try this one. All right, let's look at this. What is my y-intercept, Nolan? My y-intercept is? 1. My slope is what, Tiana? So I'm going to go down 2 over 1, down 2 over 1, or up 2, left 1. Solid or dashed line, Destiny? It is dashed line. And shade above or below? What do you say, Jeff? Above. Nice job. Now realize, always remember, negative slopes always go down. So that's always kind of a checkpoint for yourself. Recognize that negative slope, it's going down. All right, number 6 now. What happens if I'm given a problem like this? What form is always the easiest to graph? Slope-intercept form. So if I have a problem like this, what do I want to solve for? I want to solve for, well, not 2y, but actually I want to solve for just y. Okay, so if I look at it here, I write my equation over here. So x plus 2y is greater than or equal to negative 2. And again, I want to solve for y here. I want to put it into slope-intercept form. So to put it into slope-intercept form, what am I going to want to do first, Pat? Subtract the x over. Very good. That leaves me with 2y is greater than or equal to negative x minus 2. Now what am I going to want to do again, Pat? Divide by 2. Make sure I divide all of it by 2, not just the constant. Divide everything by 2. And I get y is greater than or equal to negative x over 2. What's the number in front of the x? 1. So that's really just negative 1/2 x minus 1. And then now can I graph it? Yes. So graph it from there. What is my y-intercept if I graph it from there, Jersey? If we look up on the board there, what's the y-intercept in this one circled there? I'm looking for the y-intercept. Jesse, what's the y-intercept?
-1.
Thank you, Jesse. It's -1 right there. Okay. What's the slope, Autumn? -1 over 2. Solid or dashed line? What do you say, Izzy? Solid line. And do I shade above or below? What do you say, Austin? Shade above or below? Above. There's your answer right there. All right, next one. Same idea. Okay, we're going to go through this one again. Same idea. I need to solve for y. So I'm going to have x minus 2y is greater than or equal to 4. Okay, I want to solve for y. So what am I going to want to do first here? What do you say, Colton? Subtract x. Good. I get negative 2y is greater than or equal to negative x plus 4. Now there's one detail I need to remember here. What do I need to do next? Cassie, what do I want to do next? Yes, I want to do what to both sides first? Divide by negative 2. And because I'm dividing by this negative, I need to flip my inequality symbol around. Just the same when we solve inequalities. Okay, now I get positive 1/2 x minus 2. Now I can graph it. It's in that slope-intercept form. Now I can graph. What's my y-intercept, Harvey? What's my slope, Jesse? Solid or dashed line, Tech?
Solid.
Shade above or below, Ben?
Below.
And there it is, right there. Okay, so again, remember on a problem like that, when you divide, you got to flip that inequality symbol around. Otherwise, your shading's going to be off. Okay? Last problem of the day. And I'm going to switch it. I'm not going to do that one. I'm going to change this to x is greater than negative 1. Okay, so I'm changing that to x is greater than negative 1 now. Now, I did that for a reason here, because what is the special type of line on this one? This is a vertical line. Okay, so I look at negative 1 here. It's going to be a vertical line. Now, will the vertical line be solid or dashed, Tyler? Dash. Now, here's why I look at this one. Because technically, where would I shade this? I technically shade it above, but there's no above on a vertical line. So where are the numbers that are greater when I'm looking at this?
Right.
On the right over here. Because if I look about my x number line, if I think about my x number line, all the numbers to the right are getting greater. So that's where I would shade, where everything is getting greater. Okay, so if you have an x, that's where you want to grade. And here is your assignment.